Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to learn how to graph parabolas or quadratic functions when they're given in standard form. Now, standard form would be when you have y equals or f of x equals a times x squared plus bx plus c. So you have an x squared term. You have to have an x squared term always to be a quadratic function. And you can have a bx and c term. Those don't have to be there. Now, in the previous video, we did it in vertex form, which, just to remind ourselves, I'm going to just write out vertex form. That would be a times x minus h squared plus k. Now, that a is actually the same exact a from both of them. That number will be the same for both. Now, if you go through the process of completing the square, basically, here, for these two terms, you can convert standard form into vertex form. I'm not going to go through that in this video. If you're interested, look up completing the square. But what you'll get is you'll find out that this h, once you go through the whole procedure, is going to be negative b over 2a. So whatever this b is, whatever this a is, negative b over 2a. That's going to be the x-coordinate of your vertex. The y-coordinate, there's a formula involving a, b, and c, but really it's easier. Just plug in negative b over 2a in for x, and then evaluate that. And then what is the value you get? That's what the y-coordinate will be. So the vertex is negative b over 2a, and then f of negative b over 2a. Just like with vertex form, the parabola is going to open up if that number a is positive, and down if that a is negative. The axis of symmetry is just, again, x equals the x-coordinate of the vertex. So in this case, negative b over 2a. The y-intercept is still f of 0. Example 1, graph y equals x squared minus 2x plus 3. Find the vertex, axis of symmetry, the y-intercept, and state the number of x-intercepts. So again, our standard form is ax squared plus bx plus c. So a is the coefficient of x squared, which is 1. B is the coefficient of x, which is negative 2. And c is the constant coefficient, which is 3. Now, to find our vertex, the x-coordinate of our vertex, which I'm going to call h, it's negative b, which would be 2, divided by 2a, which is 2. So that's 1. Now, to find the y-coordinate of the vertex, which I'll call k, you just plug in that number h you just found, 1, plug that in for x. So that's going to give you 1 squared minus 2 plus 3. So it's 1 minus 2 plus 3. That is just 2. And that means our vertex is 1, 2. The axis of symmetry, let's write as AOS, is going to be x equals the x-coordinate of the vertex. So that's x equals 1. And then finally, the y-intercept, you get the y-intercept by just plugging in x equals 0. That's always going to give you the constant coefficient, which is c. So the y-intercept in standard form is just going to be c, which is 3. And we can graph this now. So here's our vertex at 1, 2. It's going to cross the y-axis at 3, like we just said. And it should look like this, okay? We notice that it has no x-intercepts. Example 2, graph y equals negative 3x squared plus 6x, and we want to find the vertex, the axis of symmetry, the y-intercept, and find the number of x-intercepts. So again, our a is the coefficient of x squared, so that's negative 3. And our b is the coefficient of x, that's 6. C would be the constant coefficient, which in this case is just 0. Okay, so the x-coordinate of our vertex is just going to be, again, negative b, which is negative 6 over 2a. 2 times a would be negative 6 as well. So this is just going to be 1. The y-coordinate of our vertex, just plug 1 into the equation. Just plug this number you found for h into the equation. So you'll get negative 3 plus 6. That's positive 3. So the vertex is 1, 3. This is going to open down because a is negative. The axis of symmetry is going to be x equals 1. Again, it's x equals the x-coordinate of the vertex. And the y-intercept, that's going to be c, or the constant coefficient, which in this case is 0. Okay, so now we can graph everything. So the vertex is right here. It's 1, 3. It's going to cross the y-axis at y equals 0. So it should look like opens down, right? So it should look like this. It's going to be kind of narrow here. Okay. It shouldn't look so pointy, but sometimes they're hard to draw, so that's fine. Example 3, graph y equals 2x squared plus 4x minus 1, and find all the same things we did before. So in this one, a is the coefficient of x squared, so a is 2. B is the coefficient of x, so b is 4, and c is the constant coefficient, so in that case, this is negative 1. All right, so now finding the vertex, the x coordinate is going to be negative b, so that's negative 4 over 2a, which is 4. So that gives us negative 1. And then k, the y coordinate of the vertex, just plug in negative 1 in here and see what you get. In that case, you're going to get 2 times negative 1 squared is going to be positive 2, right? Because negative 1 squared is 1. It's going to be minus 4 minus 1. It's going to be 2 minus 4 minus 1, so that's going to be negative 3. So the vertex is negative 1, negative 3. The axis of symmetry is going to be x equals negative 1. Again, it's the x equals the x coordinate of the vertex. It's going to open up, and the y-intercept is going to be c, which is negative 1. So let's graph those points. So let's see, 1, negative 3. Here's the vertex. It's going to cross the y-axis at 1, and then it's going to open upward. So it should look roughly like that. Here's our final example. Graph y equals negative x squared plus 3, and then find the vertex, the axis of symmetry, the y-intercept, give the number of x-intercepts. So this is an interesting problem in that it's actually already in both vertex form and in standard form. You can see in vertex form, right, it's like a is negative 1, h is 0, and k is 3. If you want to do this in standard form, right, a is negative 1, b is 0, that's the coefficient of x, right? There is no x term. And then c is 3. So if you take h, it's negative b over 2a, but since b is 0, it's going to give you 0. K is going to be 3, which is what we got if we consider this to be in vertex form. So the vertex is 0, 3. It's going to open down. The axis of symmetry is x equals 0. And since it opens down, then the axis and its vertex is above the x-axis, it should have two x-intercepts. So in any case, though, if we graph this, oh yeah, the y-intercept is 3. It's c, right? So anyway, here we go. So that's the vertex. It should look like this. And it should be symmetric about its axis of symmetry, but it's not always easy to graph it like that. And that's it for graphing parabolas in standard form. It's not drastically harder to graph them in standard form than it is in vertex form. It's mostly about remembering the formula. Remember that the x-coordinate of the vertex is negative b over 2a, and then to find the y-coordinate, you just plug in that value you found, negative b over 2a, just plug in that number into the equation and find the y value that corresponds to that x value. Until next time, have fun.